Hi there, learners. This is Mr. Collins. Today we're going to do a little demo to learn a little science. Now, science teaches us that the atmosphere is made of molecules, and these molecules have mass. So if we took a column of air about 1 square inch all the way up to the top of the atmosphere and condense it down to, say, a metal bar, that metal bar would weigh about 14.7 pounds. So what this is telling us is wherever we are, we have about 14.7 pounds of pressure squeezing on us at all times. We're going to see a little demo where we are going to take the air pressure out of something and show that air pressure squeezing and compressing with 14.7 pounds of pressure per square inch. Let me see if I can put my camera down over here. There we go. Now we're stable. So what I have right here on this burner is I got a little can of orange bubbly, just a little bit of water in there. I got the burner up on high. We're burning this baby. Yeah, it's on high. It's getting warm. I'm not quite getting steam and bubbles yet. Oh, I'm seeing some bubbles. Not getting steam yet. What I want is steam to take place. See, as this water begins to evaporate, it's heating up the air around it. And this air, which is constantly moving and bumping, eventually starts leaving this can. Now, more air normally comes in to replace anything that's leaving it. However, with this heated up air, it wants to take up more space and become less dense. It wants the same amount of mass, but in more space. And so a lot of air is leaving, and there's not room for more air to come in because it is expanding. So what I'm going to do is, if I were to able to cap this can off and keep air from getting in, what would probably happen is this air inside, which would continue to expand, might blow up the can. So what I want to do is take it off the heat. I'm going to transfer it upside down into this little pool of water so it will cool quickly. And as it cools nice and quickly, we're going to see the air inside the can condenses. There's less pressure pushing outward on the can, more pressure pushing inward on the can, and what will happen is the can will implode. I'm hoping that it's been there for enough time, because right now, if I stop talking, it becomes an awkward silence. I'm going to use my clampers because I'm smart enough to know that hot things burn. So I'm going to use these babies so I don't burn my little phalanges. I hear some sizzling in there. It's telling me we got some steam taking place. It's telling me that science is ready to begin. Here we go. On 3, 2, 1. Oh, boom shakalaka. Still kind of warm. Can got crushed by the pressure from air around it. 14.7 pounds of pressure per square inch, baby. That'll leave a mark.